right, section 9.1 is the Pythagorean Theorem. Theorem 9.1 states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So one thing to remember is that the hypotenuse, which is the longest side, is always going to be opposite the right angle. Now this will become important to us as we keep going on. So we know then that using the formula, c squared is equal to a squared plus b squared. Now remember, we have already said that a and b here are the legs. All right. So a Pythagorean triple is a set of three positive integers. So that means whole numbers, ladies and gentlemen. A, B, and C that satisfy a squared plus b squared is equal to c squared. So again, they just flipped it over there. So some of the common Pythagorean triples and some of their multiples are 3, 4, 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. So again, the larger of the three of those numbers is going to be your hypotenuse. And then if you look here, for the second one, well, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and so on. So those are just multiples, and that's kind of what they're showing you down there. All right. So we can say it's 3 times x, 4 times x, 5 times x, 5 times x, 12 times x, 13 times x. So you should be able to see some of those. All right. So the most common Pythagorean triples, like I just said, are in bold, and the other triples are a result of multiplying each integer in the boldface triple by the same factor, which I'm just repeating myself. So, for examples 1 and 2, find the values of x. So, x in example 1, again, that is going to be your hypotenuse. So if we're going to use our formula, c squared is equal to a squared plus b squared. In this case, our c is going to be x, so it's going to be x squared is equal to, and then on the legs, it doesn't matter which one you use. So we're going to say it's 4 squared plus 5 squared. All right, so 4 squared is 16, 5 squared is 25. When I add those up, I'll get that x squared is equal to 41. Okay, now how do I undo a square? I square root it. So I'm going to say that x is equal to the square root of 41. Now we didn't put the plus or minus in front of it like we should do, only because they said it's going to be the positive integer. All right. So on this one here, we're going to still take the positive, but now I want you to think. The square root of 36 is 6. The square root of 49 is 7. So we know that the square root of 41 is between 6 and 7. In fact, if you put it in your calculator, you would see I'm right. And that is not an integer. So what we can state here is because the square root of 41 is not an integer, the side lengths do not form a Pythagorean triple. All right, so now let's try it for the second one here, and I'm going to change colors here. Well, first of all, let me see. So this one right here, again, there's our hypotenuse. So I'm going to change colors here just because I'm going to use that red here later on. So in this case here, again, our hypotenuse is c squared, but one of our x's is going to be a or b. So I'm going to say a squared plus b squared is equal to c squared. All right, and then I'm going to say that 15 squared plus x squared is equal to 25 squared. Now 15 squared is 225. So we're going to have our plus x squared, and 25 squared is 625. So now to get the x by itself, we're going to subtract that 225. So 625 minus 225 will give us that x squared is equal to 400. So again, to take undo a square, we're going to square root it. And the square root of 400 is 20. All right. So now that is an integer. So in this case here, so yes, it does form a Pythagorean triple. All right, and now just a simple example using the Pythagorean theorem. The flagpole shown is supported by 2 wires. Use the Pythagorean theorem to approximate the length of each wire. So again, on here, if you think about it even here, oh, I'm sorry, I did want to show you something up here. So this one here is 20, right? But I want you to see that on each one of these, okay, and that's why I wanted to go back, we know that that is 5 times 4, right? This one here is 5 times 5. And this one here is 5 times 3. So if you look at it on here, again, we were talking about how it's a multiple of the 3, 4, 5. So here's our 3, here's our 4, and here's our 5, and it's being multiplied by 5, all right? So I thought that was a good example for you. And now let's go back to the example 3. The flagpole shown is supported by 2 wires. So again, there is my hypotenuse. So we can on this one here say x squared is equal to, well, 8.5 squared. Because again, we're looking at one triangle right here. Okay, so that's 8.5 squared plus 15.1 squared. Okay, now your calculator will be as nice as you want it to be. So you could go ahead and do this radical and do everything underneath it. So 8.5 squared plus 15.1 squared. And then it would ask you to approximate it. So we would say 17.33 feet. Okay. And let's see here. Now we can use the converse of the Pythagorean theorem to determine if a triangle with given sides is a right triangle. So the converse of the Pythagorean theorem states that the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other 2 sides, then the triangle is a right triangle. Okay? So basically what that is saying here is if, in our drawing here, c squared, because that does look like the longest side, is equal to a squared plus b squared, then triangle ABC is a right triangle. So that's saying we would be able to put a right angle symbol there at C. All right. So example 4, tell whether each triangle is a right triangle. All right. So we're going to let C be the length of the longest side. So if you're not sure if 12 is the longest side, we know it's definitely longer than 8. You might need to plug in 4.5 in your calculator, but I will let you know that it is in this case here. So we're going to say then that C squared is equal to A squared plus B squared. So we're going to say 12 squared is equal to 8 squared plus 4 times the square root of 5 squared. Okay, now I want you to think on that one there. Those two are going to be the same, right? But if you want to think about it, that 2 is going to both of those. So we would have 4 squared and the square root of 5 squared. Okay, so 12 squared is 144. 8 squared is 64. 4 squared is 16. And let me write my 16 a little better. And remember, the square root of a number squared is just the number. So if you want to think about it, what I just said there is that these two kind of cancel each other out if you want to think about it that way. And what's left underneath is the 5. So we are going to say it's times 5. All right. So 144 equals 64 plus 80. So we have 144 on this side. 64 plus 80 is 144 on that side. So we would say yes for A. For B, same thing. I would plug it into the calculator to see which one would be the longest side. And again, on this one here, it's going to be 14. So I'm going to say 14 squared is equal to 9 squared plus 2 times the square root of 30 squared. Okay, so I'm going to say 14 squared is equal to 9 squared plus, just like I did on the other one, we're going to say it's 2 squared and the square root of 30 squared. So 14 squared is 196. So the easy way to remember that is 13 squared is 169. 14 squared is 196. So the 9 and the 6 flip. That's an easy way to remember it up to 14. Okay, so we know 9 squared is 81. We have plus 2 squared is 4. And again, the square root of 30 squared is just going to be the 30. So now 196. And we're going to say that's 81 plus 120. So we have 196 on this side. On the other side, we have 201. Well, those do not equal each other. So on this one here, move it up. I'm going to say it's a big fat no. All right. And our next and final thing is the theorem 9.3, which is the Pythagorean inequalities theorem. For any triangle ABC where C is the length of the longest side, the following statements, I guess I need to fix that, are true. So if C squared is less than A squared plus B squared, then triangle ABC is acute. And if C squared is greater than A squared plus B squared, then ABC is obtuse. Remember, when it's equal, we just said it was going to be a right triangle. So, example 5. Verify that the segments with the lengths 14 meters, 15 meters, and 11 meters form a triangle. Then the second part of it is the triangle acute, right, or obtuse. So verify that the segments form a triangle. Are the sums of the two sides greater than the third side? So what it is asking us there is, I'm going to take 14, 15, and 11, and I'm going to add 2 of them, and then they should be greater than the third side. So step 1, we're going to say 14 plus 15. Again, it's a question. Is that greater than 11? Okay. 14 plus 11. Is that greater than 15? And then 15 plus 11. Again, we're going to ask, is that greater than 14? All right. So 14 plus 15 is 29. 29 is greater than 11. So that one checks. 14 plus 11, that's 25. 25 is greater than 15, so that side checks. And then the last one, 15 plus 11, that's 26. Is that greater than 14? And yeah, that one also checks. If one of them didn't check, then we would be done. All right. So what we can say is, so the segments do form a triangle. Okay, and then the second step is classify the triangle by comparing the square of the longest side with the sum of the squares of the other two sides. So my suggestion to you would be to do something like this. I'm going to put C squared. I'm going to leave this as a blank, and I'm going to fill in that blank at the end. It's either going to have a greater than symbol, less than symbol, or an equal symbol. And that will tell us if it's right, obtuse, or acute. So C squared blank A squared plus B squared. Which is your longest side there? If we look, it was 15. So we're going to say 15 squared. Again, we're going to put a symbol there in a second. And then we're going to have 11 squared plus 14 squared. Okay, so 15 squared is 225. 11 squared is 121. And 14 squared, I just told you earlier, it was 196. So again, this side still stays the same. And 121 plus 96 is 317. So what are we going to put in that symbol there? So 225, is that greater than, equal to, or less than 317? You're going to tell me it's less than. So C squared is less than A squared plus B squared. And according to what we just said up above, it is going to be acute. So c squared is less than a squared plus b squared, and the triangle is acute. Okay? Thank you, people.